Welcome to Cheenta Statistics and Data Science. Today we are going to solve this problem from IIT JAM-MS 2022, problem number 44. The problem says that let x and y be two independent and identically distributed random variables having uniform 0-1 distribution. Then probability x squared less than y less than x equals round off to two decimal places. So basically we need to find the probability that y lies between x squared and x. So at first it might seem a bit difficult to just look at the probability, and it might seem a bit difficult that the problem is a difficult problem. It might seem, but it's actually a very easy problem. So x and y follows IIT uniform 0-1, right? And we need to find the probability that y lies between these two quantities, x squared and x. So basically the joint PDF of the random vector xy is nothing but fxy is equals to 1 if both of the x and y lies between 0 and 1 and 0 otherwise. The PDF is 1 if x lies between 0 and 1 and y lies between 0 and 1 and 0 otherwise. This is the PDF, joint PDF of xy. So basically this is nothing but we have to integrate the region on which this is true. We have to integrate the PDF over the region on which this is true. So how do you find this region? It is very easy. First, we need to know the support of the distribution, which is this interval 0, 1 on the x-axis and again 0, 1 on the y-axis. That means this thing, this square, this unit square is actually on which the PDF, this is the support, this is this part, this entire square is the support. This square is the support of the PDF. That means on which the function is positive and elsewhere the function is 0. That means this basically you can imagine that there is a this entire thing is actually a cube. There is a sheet hovering over this particular this region, over this square at the distance of 1 units on the z-axis. You can imagine that is the PDF of fxy, right? That's the PDF of xy. That function fxy is hovering over this particular this square at a distance of 1 units from origin on the z-axis. So now we need to find the probability that y lies between x squared and x. So that just means that if we draw this function, this y equals to x is this curve, this line, and y equals to x squared is this line. So every point that lies in between these two curves, obviously, these two curves, this y equals to x and y equals to x squared, these two curves, as you can see, these two, every coordinate that lies between these two regions, the region curved, the region closed by these two curves satisfies this thing, they satisfy this property, right? Every coordinate that lies in between these two curves and obviously lies in between the square, otherwise the PDF is 0, I mean, outside this curve, so outside this square. So every point which lies in between this curve, these two curves, contributes to the probability that y lies between x square and x, right? So basically we need to find the integral of this, the function over this region, the integral of the PDF, the joint PDF over this region. Now how do we find that? We first change x coordinate, so x running from 0 to 1, integral x running from 0 to 1, and then for each value of x, y runs from x squared to x, right? Suppose x is this value, suppose x is this value, then y runs from this value to this value, right, up to this, confined within these two curves, right? Again for x is equals to this value, y lies between these values, right? So in general, when x moves from 0 to 1, y moves from x squared to x, and, the entire the integrand is nothing but the joint PDF of xy, which is 1, of course. So now this is just nothing but integral 0 to 1 integral x squared to x dy dx, which is very easy to calculate, right? It is nothing but 1 by 6, which is 0.166. So the basically all you needed to do for this problem was just know how to use the definite integral, right? Any function, it could have been any other probability, right? The probability of something y belongs to some other region, that would have been the integral of over that region, if the integral of the joint PDF over that region, right? That is the main idea, nothing else. That is the main idea. It's a very easy problem. All you needed to do was the probability of the thing. That means the double integral. You need to know how to calculate the double integral. That's it. So there you have it, the solution to this problem. So do like, share and subscribe to the channel for more exciting problems. See you till next time.